All right, now we're going to get to the only type of transformation that is not isometric. So after the transformation occurs, specifically this dilation occurs, the objects won't have the same lengths of sides, but the angles will be the same. They'll be similar, but not congruent. Okay. So here I have, there's two types of dilations really. There's dilations about a point on the object, on the figure, and then there's dilation about like the origin. I'll show you how to do both. Okay. Now something we need to know about dilations is this key term called a scale factor, and the scale factor is the multiple by which like we're going to multiply the length of the line segments by in order to grow it or shrink it, and it's known as K. And if K is greater than 1, it's a growth. If K is between 0 and 1, it's a shrink. Okay, so let's say I have this triangle ABC. Okay, we'll say that triangle A prime B prime C prime is a result, results from, we'll just do that, it's shorter, results from a dilation of triangle ABC by a scale factor, we'll just say K, by a scale factor of 2. All right. So that means center of dilation, we'll say center of dilation is point B. All right. So center dilation is point B. That means that this line is going to grow by a factor of 2. This line is going to grow by a factor of 2. And since those angles are going to stay the same, this line will consequently grow by a factor of 2. All right, so in order to grow this isn't just a straight up and down line, or it isn't just a left and right line. You have to grow line segment AB by a factor 2 by growing its change in Y by a factor 2 and its change in X by a factor 2. So let's look at AB, the line segment AB, and we're going to grow that by a scale factor 2, meaning we're going to double the distance. Both components, the change in X and the change in Y. Okay, so the change in X from AB is 2, and from the change in Y in AB is 3. Okay, when I apply a scale factor of 2 to that, it's going to double this, 4 and 6. All right, so now instead of being 2 and 3 away, it's going to be 4 and 6 in the X and Y direction. Right, and of course, in order for it to grow this way, it's got to go over 1, 2, 3, 4, and then it's going to go down 6, 1, 2, 3, 4, 5, 6. Okay, and you notice that this is on the same line as AB. I just extended that, okay? And it also, and hey look, this line is the same as that line. It's double, right? So this is A prime because I'm growing it at a center of dilation of point B, okay? Now if I look at BC, line segment AB, or BC, the change in X is 1, 2, 3, 4, and the change in Y is 1, 2, 3, 4. So it's a 4 by 4 change. So now if I apply the scale factor of 2 to that, it's now the new line segment of BC prime is going to be double that, which is 8, and double that, which is 8. Did I count that right? 1, 2, 3. I didn't count that right. B to C didn't look like a square. It's 3. So this is going to be 6. Okay, so now the new C, the x component is going to be 6 over. 1, 2, 3, 4, 5, 6, way over here. And it's going to be 8 down. 1, 2, 3, 4, 5, 6, 7, 8, right there. This is the new C prime. Okay, and you'll see that it lines up on the same line. I think I miscounted again. Let's count that again. 6 over 1, 2, 3, 4, 5, 6. Yeah, miscounted. 6, and then 8 down. 1, 2, 3, 4, 5, 6, 7, 8. I was 1 over. So I caught my mistake by using a nice ruler here. So it continues. It uses that line, but it extended all the way to my new C prime point. And I'll just connect these two dots to make line segment A prime, C prime, and there I have dilated this triangle by a scale factor of 2, right? Recognize that this angle and this angle are the same. This angle is the same angle for both triangles, and this angle and this angle are the same. Okay, that is a characteristic of a dilation. The angles are same. The line segment lengths are similar. Okay, so BC is similar to BC prime. In fact, in that it's a 2-to-1 ratio. This line segment is 2 times this line segment. This line segment is 2 times this line segment, and this line segment is 2 times that line segment. Okay, the line segments vary by the scale factor. Okay, that is similarity. Okay, it's like a congruent sign, but it doesn't have the equal sign underneath. Okay, so there is that dilation. Let's move on to a dilation about a point, like the origin. Okay, so I have a coordinate plane here, right? And I'm going to say that A prime, B prime, C prime, the triangle I'm going to make, results from a dilation of triangle ABC by a scale factor of, we'll do 1/2 this time. We're going to shrink it. Okay? With a center of dilation about the origin. Okay, so now I'm not looking at the distance between these ones. I'm looking at the distance between each point and the origin. Okay, so let's look at A in the X and the Y direction. We'll look at B in the X and the Y direction. I guess I don't have to do that again. And we're going to look at C in the X and the Y direction. My 3 points. Okay, and then I'm going to apply a scale factor of 1/2 to get A prime, B prime, and C prime, and their respective X and Y's. All right, so let's have at this. So what is the distance between each from A to the origin? Well, it's pretty obvious. It's just a coordinate point, right? So the X direction is 2. The Y direction is -1, 2, 3, 4, 5. For B, the coordinate point is 5, 1, 2, 3, 4, excuse me, 4, and -2 for Y. These are just the coordinate points, 2 and -5, 4 and -2. And then C is over 1, 2, 3, 4, 5, 6, 7. And it goes down 1, 2, 3, 4, 5, 6. -6. Okay, so now all I got to do is divide each one of these by 2 to get the new coordinate point for the prime point. Okay, so half of 2 is 1. Half of -5 is -2.5. So let's plot that. So it's going to be a 1 and -2.5. This is now A prime. Okay, now B prime, divide 4 by 2, and it's 2. Divide -2 by 2, that's -1. So this is now going to be at 2 and -1, right there. Okay, and then my final one is going to be -7, which divide that by 2. This is a prime. Divide that by 2. I get -3.5, or sorry, 3.5. And divide -6 by 2, and I will get -3. Okay, so this is going to be 3.5 over right there, and then going to go down 3. Yep, 1, 2, 3. There is my new dilated triangle. Like this. This is A prime, this is B prime, and this is C prime. Okay? And you may notice that this is half the distance. Well, it's not half. It has some scale factor because the point is from here. Okay? But this angle and this angle are the same. This angle and this angle are the same. And this angle and this angle are all the same. But the line segments are all, these are smaller line segments, but they're all smaller by the same factor. Now, if you look at this, well, that factor is 1/2. Okay. Now, I know that this was the center of dilation because if I take, where's my green marker? I'll use purple. All right. If I take my B's and I line them up, you'll notice that they line up with my center of dilation. My C's line up with my center of dilation. And my A's line up with my center of dilation. Right? So that is, those are 2 dilations. One is a dilation about a point and it's a shrink by about the origin and it's a shrink, and the other dilation